In this video, we are going to cover Chapter 8, Section 5, the Kinetic Molecular Theory. Now, I've jumped ahead here after Section 1, talking about gas pressure, to cover this Section 5, the Kinetic Molecular Theory, and then we're going to transition into the gas laws. But I thought it was important to talk a little bit more about the composition makeup of gas before we get into the quantitative relationships. As always, here are the learning objectives, so please pause the video and write these down in your notes. One of the learning objectives here, use this theory's postulates, the kinetic molecular theory's postulates, to explain the gas laws. We're not going to quite do that in this video. We're just going to kind of build the foundation, set the table of how gases behave, the variables involved, and the explanation of some of those variables, which is the kinetic molecular theory. In the next section, when we get into the gas laws, before we get to the gas laws themselves and the quantitative analysis dealing with the different variables, we'll talk a little bit more about the relationship, the qualitative relationship between these variables. To start then, I've listed the gas variables here. So we've already talked in the first video about pressure and being able to understand that pressure is the collision of the gas particles with the walls of the container. So what we want to do, what we'll attempt to do in the next unit, is talk about the relationships between the variables. Well, here is a list of what those variables are. Anytime I'm dealing with a gas, I have these four variables in play: pressure, volume, temperature, and amount. And the relationships that develop from how these variables interact will make up the gas laws. For now, just wanted to introduce these so that we're comfortable as we get into talking about the properties of gases. We have in the back of our mind what the measurable variables will be as we get into some quantitative analysis later. Here are those properties of gases. Please pause the video and take a minute to write down these properties. All gases exhibit these properties that you see listed here: have a mass, fill their container, easily compressed, move past each other, exert a pressure, and that pressure depends on its temperature. The reason why these properties exist, or the explanation of these properties, is known as the kinetic molecular theory. So here I have a list of the postulates of the kinetic molecular theory, and you will see here the connection between these postulates and the properties that you just wrote down in your notes. You may also pause here for a second to write down these postulates for the kinetic molecular theory. Now I just want to connect the dots here between the properties and the kinetic molecular theory. So the first kinetic molecular theory postulate states gases are composed of large number of particles that behave like hard spherical objects. If we don't always, I think of gases in this fashion, the air in the room around us. But if we were to think of gases that they are actually made up of hard spherical objects, then it makes sense to us that they would have a mass. We would expect a hard spherical object to have a mass. So gases have mass, even though, like I said at the beginning, we may not think of them in that way. They have mass because they are made up of hard spherical objects. The other property, the next property that was listed here, gases fill their containers completely. That again is part of this first postulate. Gases are composed of large number of particles that behave like hard spherical objects in a state of constant random motion. So those gas particles, as we have seen for many years in our study of science, that gas particles are free to move about their container. So because they move in this constant random motion, they would fill their container completely. When we talk about volume, when we get to the gas laws, the volume of a gas is the volume of the container in which the gas is being held. So that takes care of the first two properties. It is easy to compress gases. Volume of a gas can be reduced considerably. If we think about the diagram of the picture of gas particles moving freely about as they fill their container completely, we understand that the particles are much smaller than the distance between the particles, this second postulate here of the kinetic molecular theory. So most of the volume of the gas is therefore empty space. That being said, we can compress the gases. We can change the volume of the container and compress the gases because we can just take up or take away that empty space and push the particles closer together. Gases exert pressure is one we've already talked about. The importance of pressure as a concept, and will be even more so as we talk about the relationships between the variables. But these next couple postulates, particles move in a straight line until they collide. So particles are moving in straight line, they collide with one another, or they collide with the walls of the container. When they have that collision with the walls of the container, that introduces pressure. The important thing about this is the next postulate that these collisions are perfectly elastic. So that means every time a collision happens, no energy is lost. So the particles are coming in with the amount of energy, and after the collision, they're leaving with the same amount of energy. This is different from what we experience in our everyday life. If I think about dropping a ball from my hand, the ball doesn't strike the ground and bounce all the way back up to my hand because when it strikes the ground, energy is lost. So it doesn't have enough energy to get back up to my hand. And with each successive collision with the ground, more energy is lost until it finally stops bouncing. That does not happen with the collision of gas particles, so we don't have to worry about taking that into account or how pressure would change over time. If it's an enclosed container, those particles are colliding and moving, and no energy is lost from those collisions. This postulate about moving in a straight line also helps to explain how different gases can move past each other quite rapidly. So the gas particles are moving. In addition, the majority of the space is of the volume is empty space between the particles. So there's plenty of space for the particles to move past one another, and those particles are moving in straight lines. Additionally, with the pressure and the idea of perfectly elastic collision and no energy being lost, there's no additional force of attraction between the gas particles or between the particles and the walls of the container. So there's no need to factor any additional force of attraction into the pressure. It simply comes from the collision of those particles with the walls of the container. And finally, the last property, the pressure of a gas depends on its temperature. We're going to talk certainly about this in the next section when we talk about our gas laws and those four variables. But the average kinetic energy of a collection of gas particles depends on the temperature of the gas and nothing else. So we know that that is a function. Temperature is a measure of the kinetic energy. So same thing here with the gases. The average kinetic energy is going to be dependent. How much those gas particles move is going to be dependent on the temperature of the gas. Okay, so that was a short one. This wraps up section 5. So now at this point, having talked about pressure and units of pressure and how we measure pressure in the first section, and the relationship of the variables and why gases behave the way they do, we are set up to move into the next sections of chapter 8, where we will start to really get into the quantitative relationships, the mathematical relationships between the various variables as we talk about the gas laws.